In the first part of this series, we figured out how to pull detailed Formula One telemetry, everything from speed traces to throttle application and brake usage, for every driver's fastest qualifying lap across the 2023, 24, and 25 seasons. Now that we have the data, it's time to do something far more interesting. Turn the raw telemetry into a complete data-driven profile of every track on the Formula One calendar. Our goal is to understand how each circuit is driven, not just the layout, but the behavior it forces out of the car and the driver. To do that, we derive a set of metrics that capture the character of a lap. Together, these form a complete telemetry-based fingerprint of each track. There's a link in the description to the first installment and to an article with more detail. There is one complication. The car telemetry and the location data aren't synchronized. They're recorded by different sensors at slightly different times. Fortunately, both streams are sampled at roughly 4 records per second, which is consistent enough to work with if needed, and it is possible to use the timestamps to interpolate the location for each record in the car telemetry. Maximum speed comes from the official speed trap, which is usually at the end of the longest straight of each track. If that value is missing, we'll fall back to the highest recorded speed in the telemetry. Since the car telemetry is discrete rather than continuous, we'll need to estimate how long each data point lasts, and we do this by using the timestamps before and after it, splitting the difference. This allows us to interpolate the time at full throttle. Throttle data also isn't perfect. Sometimes it never reaches 100%, and other times it exceeds it. So any value at or above 95% counts as full throttle. With this method, Monza, the temple of speed, unsurprisingly comes out on top. 73.3% of the lap at full throttle. Monaco sits at the bottom with just 43.1%. A similar calculation is done to get the time under braking, and Monaco now leads the field with 26.1% of the lap spent braking. Jeddah, despite having no less than 27 official corners, only requires braking for 8 of them, and the time under braking is the lowest of the season at 12.5%. A braking event starts when the brake is pressed for at least 2 consecutive records, and the speed of the car decreases. It ends when the brake is released, the throttle rises above 50%, or the car starts to accelerate. Severity is based on how much speed is shed and how quickly. The hardest braking event across all 3 seasons? Alex Albon at the 2025 Canadian Grand Prix, dropping 204 kilometers an hour in just 1.9 seconds, while desperately working to avoid the infamous Wall of Champions on the outside of turn 14. This is different from the cornering speed, which is simply the minimum speed during a braking event. For example, Albon's slowest point on that same lap was the turn 10 hairpin at just 62 kilometers an hour. Gear changes reflect something about the complexity of each lap. Normalizing the number of changes by time instead of just using the raw number lets us compare tracks of different lengths. Elevation change is the difference between the highest and lowest points on the track. Melbourne is nearly flat at 2.5 meters, while Spa climbs an incredible 102 meters. Since steering angle isn't recorded, we have to infer turning from changes in the car's location. We'll look at turn 1 from Spa-Francorchamps, and we'll put Haas's Kevin Magnussen in the car during the qualifying session for the 2024 Belgian Grand Prix. The car records the location roughly every quarter of a second, and this allows us to follow it through the turn. Once we have the location of the car through the turn, we can compute the bearing or the heading of the car from one point to the next, and then get the difference in the heading between two stretches. This tells us how much the car has turned. Add it all up through the whole corner, and this gives us the angle of the full turn. In this case, Kevin turned 147 degrees in 4.4 seconds. Using this method, Spa had between 20 and 23 turns, depending on the driver and the conditions during what was a wet qualifying. Instead of using the official track length, we compute the actual distance each driver traveled. Small differences reflect different racing lines. Larger differences usually indicate telemetry errors, which are resolved. With all these metrics combined, we now have a complete telemetry-based profile for every driver's fastest qualifying lap on every track across the 3 seasons. This gives us a standardized, data-rich way to compare circuits based on how they're actually driven, not just how they look on paper. The next step is to group tracks together with similar driving characteristics. Do certain circuits have similar profiles? Do some tracks form natural clusters based on throttle usage, braking patterns, or corner profiles? We're about to find out, and those insights could unlock entirely new ways of analyzing driver performance and car behavior. Stay tuned for part 3.